Hello everyone. I'm going to go through the combined gas law, but also try to portray to you all something that I feel like is a little bit easier when you're going through and trying to, let's say, memorize all of the equations for Boyle's law, Charles' law, Gay-Lussac's law. And when we combine them all into one, if you know the combined gas law, then you can pretty much solve for any of the other questions that you're asked with dealing with gas laws. So I'm going to show first. You've already probably watched the video on this or seen the handouts and all the information, but we can combine the Boyle's law, Charles' law, and Gay-Lussac's law into one combined gas law that's shown here. However, I feel like the easiest way to memorize this equation, and you got to be sure that you memorize it correctly, of course, but I feel like the easiest way to remember this is to say P1 V1 T2 equals P2 V2 T1. Okay, so the main thing you got to remember here is it's not P1 V1 T1 equals P2 V2 T2. Okay, you've got a 2 here and a 1 here. But basically this is just rearranged. Okay, but I find that my students have a better time rearranging or memorizing this, and they seem to get the algebra correctly more times than not. Okay, and so if we look at what the Gay-Lussac's law, Charles' law, Boyle's law all come together, we're basically just combining it all into one equation. Okay, so why can't we just use this one equation all the time? Okay, so we'll show it first, which the most common way that we would use this is when we have all three variables that are involved. And so it's obvious that you would use the combined gas law. So if we have a gas that has a volume of 675 milliliters, so here's our V1, 35 degrees C, we know we have to add 273 to get 308 Kelvin. That's our unit for temperature for gas laws. And we have an 0.850 atm pressure. And we want to know what the volume of the gas at negative 95 degrees C and a pressure of 802. Okay, so when you have more than one variable that's going on, or you have three, you may be, doing something or increasing the temperature, which you would think would increase pressure, but then you may be doing another variable that may counter or be opposite of what the result would be with just two variables. And so here we've got a T2, that's 178. Okay, we got a 273. V2 is what we're solving for. Okay. And we've got 802 millimeters mercury. Okay, so right here we're given atm and we're given millimeters mercury. Okay, so we've got to convert to one or the other. They have to be the same. Okay, so one way we can do this is looks like here we left it in millimeters mercury, which we know is also equal to torr. Okay, but we can convert our atm to millimeters mercury. Okay, so I'll pull out our calculators, make sure this is right, but we've got 0.850 times 760, so we should get 646 millimeters mercury. Alright, so we have to do that conversion step first. Okay, so now we know our combined gas law, and if you would like to memorize it the way that I've shown, I think that's easier. That's how I'm going to do it. And so what I like to do instead of this, okay, we're just going to say P1 V1 T2 equals P2 V2 T1. Okay, and then we are going to plug in. Okay, so here would be the way. If you rather do it this way, you are welcome to it. All right, but if you want to do it this way, let me move forward here. So P1 so we're solving for our V2, Okay, and so if we use this equation, I just feel like it's easier for people to see. And so if we're solving for V2, we want to leave it by itself. So we would be dividing through by T2 and T1. Okay, and so it remains to be the same here. So once we plug in the values, we have pressures 646 times the volume, and we have the T2 on top, T2 on the bottom, T1 on the bottom. So maybe better if I go ahead and write this out here. So V2 would be equal to P1 times our V1, which was 675, times our T2. I think our T2 was 178. Okay, so I'm plugging in actually this arrow here, just to be sure you see it both ways. Our P2 is 802, and our T1 was 308. Okay, so everything cancels except for milliliters, so our units here cancel, 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 and we should be left with 314 milliliters. So I'm going to check that real quick. Okay, and that works. And now we are going to look at how we can use the combined gas law again, or we can use it just about every time, even when we're just using Boyle's law or Charles' law or Gay-Lussac's law by itself, because it's all set up in the equation, and we can just, variables that we're not concerned with, we can just leave them out. The point of this section is just to show you that you can go ahead and memorize the equations for Boyle's, Charles, Gay-Lussac's law. That might be the easiest for you. But you can also just take the combined gas law and look at your variables and see which ones you need. Instead of memorizing them all, you can use the one equation and use it for all of the equations. So if we look here, you do want to recognize that we're dealing with volume and pressure. And so the law that deals with volume and pressure is Boyle's law. Okay, so if you increase the pressure, you're going to decrease the volume. So they have an inverse relationship. And so you could go ahead and if you want to just plug in Boyle's calculation, then you could just do so. Okay, but another way that you can do this is by just using the combined gas law. So if we know the one equation, we should be able to come up with all of our equations or all of our answers for gas laws by just using the combined gas law for Charles, Boyle's, or Gay-Lussac's. Okay, so the first thing we see is we have a volume of 5 liters, so that's going to be our V1 is 5, our P1 is 1, and what's going to be the new pressure? So we want to find P2. So this is a big part of these calculations, is knowing what you're looking for. And if the volume decreases to 2 liters, and there's no change in T2 or T1, or in the amount of gas, so that would be N. Okay. So all we have to do here is we know that T2 and T1 are constant. So either you can just remove them out if you would like, or you can keep them there and just use a constant number, so 273 and 273, however you'd like. But I use anything that doesn't change, I just kind of cross it out there. Okay, and then we're going to be solving for P2. So P2 would be equal to P1, V1 over V2. Okay, so our P1 was 1, our V1 equals 5. Should be using that 1 ATM. And our V2 is 2 liters, so everything's in liters, so that will be fine. And so if we do the math, we should get 2.5 ATM. Our liters will cancel our units, and we're left with ATM. Here is another way that we can use the combined gas law. We don't necessarily have to use Boyle's or Charles or Gay-Lussac's law. We can use the combined gas law, and then we can cross out variables that are constant. Instead of having to memorize all 4 laws, we can just use one and plug in for what we need or for what changes. So here we have a sample of gas that's 5 liters and a temperature of 15 degrees. We want to find the new volume if the temperature increases. So right away, you would want to think of Charles's law as dealing with your volume and the temperature. And we know that if the temperature increases, then the volume increases and vice versa. Okay, but if you didn't want to go through and memorize all of these, you could just write out your handy-dandy P1, V1, T2 equals P2, V2, T1. Okay, so if we look here, we've got V1 is 5.40 liters, and T1 is going to be 15 degrees C plus 273, so that will give us 288 Kelvin. Okay, and then we've got a new volume is what we're trying to find. And our T2 is 42 degrees C, so we're going to be increasing our temperature, so we're going to get 315 K. Okay, and then we notice we've got pressure up here, but we have P1 and P2 are constant. So you could just put a 1 in there if you wanted to for 1 ATM, or you can just, if it's constant, then you don't have to use them. So what I do is just go like this, because P1 and P2 are constant. They're not going to change. They're not going to change our answer. And so then I solve for V2. So we would have V2 equal to V1 T2 over T1. So V1 is 5.40 times T2 is 315 Kelvin divided by 288, and this should give us our V2. So V2 should be 5.91 liters. Check just to be sure. So you want to have your calculators handy, be sure you check. Yep, so 5.91 liters would be our new volume. And this is just showing you that you can use the combined gas law for all of the laws, and it'll work out just the same. Just cross out what is constant and doesn't change, and that way you just have to memorize one equation and go from there. Thank you, and